Okay, we've got a minivan. It's tested for acceleration and braking. Okay. During the acceleration test, it takes 8.2 seconds to go from 10 to 100 kilometers per hour. Braking test takes 44 meters to stop from that 100 kilometers per hour. Assuming constant values of everything, determine a whole bunch of stuff, and we'll go through that as we will. Now, the first thing I need to do is go from kilometer hour to meters per second. Okay, get everything in meters and seconds. That's the best way to go about this. So I'm going to start with 10 kilometers per hour, and that's going to go 1,000 meters in every kilometer, and divide that by 3,600 seconds in every hour to go from kilometers per hour to meters per second, which means that 10 kilometers per hour is 2.78 meters per second. Okay, 100 kilometers per hour is equivalent to 27.8 meters per second. So those are the values that we're going to use for this process. Now, because the acceleration is constant, I can use those algebraic equations for constant acceleration. Okay, so I've got time and I have two velocities. Okay, and I want to find the acceleration. Okay, so I'm going to use this equation here, which relates to velocities, starting and stopping velocity, and the constant acceleration that I'm trying to find at a specific time. So my final velocity, 27.8. My initial velocity, 2.78. My acceleration is what I'm trying to find. This occurs over 8.2 seconds. Okay, so from this I can calculate that acceleration to be 3.05 meters per second squared. Okay, and again, I can only use this equation because that acceleration is constant. Okay, I can use these um, algebraic equations in order to do that. Okay, now the second one, it wants me to find the deceleration of the other problem. Now this one is based on position, right? I've got an initial and final velocity and then a distance traveled. So I'm going to use the equation without time in it because I don't care about the time on this one, right? I have my initial and my final velocity plus 2ac and then the change in position that I have right here. Okay, so my initial velocity here is 20, well, no, I'm sorry. We start with my final velocity. I end at 0. My initial velocity is 27.8 squared. Okay, and then I say plus 2 times the acceleration that I'm trying to find, times, again, it travels 44 meters, like so. From that, I can find that the deceleration is negative 8.77 meters per second squared. And again, I can use these equations because the acceleration is constant, okay? And I use the equations that have velocity, relate velocity acceleration to position. Time is not of interest, so that's the equation that I use there. Now it wants to know the distance traveled during the acceleration portion. So now I can bring in, again, I've got time. This time I want to deal with position. I already know my acceleration now, so I'm going to use the equation s equals s naught plus v naught t plus 1/2 at, like so. Okay, and again, I'm trying to find the distance traveled here. So I'm going to go ahead and plug in my values here, my initial position. Now let me do it this way. Okay, s equals 0. My initial velocity, again, remember it is 2.78. Okay, my time, I don't know my time. That's what I'm trying to figure out. No. My time is 8.2. Excuse me. Okay, and my acceleration I found previously is 3.05, and my time is 8.2 squared. From this, I can find my position at this point to be 125.3 meters. Okay, and again, I can use this equation because I know my acceleration is constant. I've already calculated that acceleration to be 3.05, and I just plug in the 8.2 seconds to figure out how far it travels during that process. I also want to find the time elapsed for the braking, right? So I know the deceleration. Now I want to bring time into it, and I know my two velocities. So I'm going to go back to that first equation that I used, that the velocity equals the initial velocity plus the acceleration times t, right? So coming to rest, final velocity is 0. My initial velocity, again, is at this deceleration, again, I started at 27.8. My deceleration is 8.77. Take that times time. So from this, I can calculate what that time would be, and I get that time equal to 3.17 seconds. Okay. So again, the main thing to recognize is once I know that I have constant acceleration, I can use these algebraic equations. But of course, these equations only work because my acceleration is constant. But once I have that, then these equations become pretty simple. You just choose the equation that gives you the value that you need based on the values that you have.